Today, we're diving into a really powerful idea for healing our planet, and we're going to zero in on India. We're going to see how some of the smallest, tiniest forms of life might actually be the key to solving some of our absolute biggest environmental problems.
I mean, it sounds like something straight out of science fiction, right? The whole idea that we could use living organisms to clean up our worst pollution, our biggest messes. But here's the thing. This isn't fiction. It's a real and a rapidly developing field of science.
And this is exactly why that science is so important. You know, the reality on the ground is pretty stark. For all their incredible cultural and historical meaning, so many of India's vital rivers are facing this massive crisis from pollution. It really sets the stage for a monumental cleanup challenge.
So, to really understand the solution, first we have to get a handle on the sheer scale of the problem. India's rapid growth has been amazing, but, it's also come at a really heavy environmental price.
And here's the thing, we're not just talking about one kind of pollution. It's a whole messy mix. You've got industrial oil leaks, runoff from pesticides used in farming, and toxic heavy metals just seeping into the soil. And the way we've traditionally tried to clean this stuff up, well, it's super expensive, it uses a ton of energy, and honestly, sometimes it just creates a whole new set of problems.
But what if there's a better way? This is where we get to the really cool part. Let's meet nature's very own, highly specialized cleanup crew.
This phrase just perfectly captures the whole idea, doesn't it? It's not about fighting nature with more harsh chemicals. It's about working with its own built-in systems to heal and bring things back into balance.
And here's the official name for it, bioremediation. At its core, it's all about using these tiny living things, bacteria, fungi, you name it, to do a huge job. They basically eat harmful pollutants. That's their food. And what's the result? They break those toxins down into stuff that's totally harmless, like plain old water and carbon dioxide.
So, how in the world do you go from a horribly polluted site to a clean one using just microbes? Let's get into the nitty-gritty of how this amazing process actually works.
Okay, so there are two main strategies here. On the left, you've got in situ, which is just Latin for in position. This is where you treat the contamination right where it is. A classic example is spraying oil-eating bacteria directly onto an oil spill in the ocean. Then on the right, you have ex situ. This is where you actually dig up or pump out the contaminated soil or water, treat it somewhere else in a controlled facility, and then put it back once it's clean.
And the process itself is it's so elegant. First, scientists figure out exactly what the toxic stuff is. Second, they introduce the right kind of microbes, the ones that see that pollutant as a delicious meal. Third, the microbes just go to work, eating and breaking down the pollutants. And finally, all that's left are safe, natural byproducts. The threat is just gone.
And this is where the story gets a seriously high-tech upgrade. See, we're not just limited to the microbes we happen to find in nature. Thanks to modern biotechnology, scientists can actually engineer what you might call supermicrobes. These are genetically modified organisms, or GMOs, specifically designed to break down the toughest of the tough pollutants, things like plastics and stubborn oil gunk that natural microbes just can't handle. Okay, so with all this incredible potential, where does India actually stand today? Let's bring our focus back to the current situation and take a look at both the exciting progress and, the real-world hurdles. This table gives us a fantastic snapshot. On the left, you can see there's a lot of momentum. You've got government groups like the Department of Biotechnology, the DBT, and research institutes like CSIR-NEERI really pushing things forward. We're also seeing amazing innovation from the IITs and a whole bunch of new specialized startups popping up. But the challenges on the right are very real. There aren't any unified national standards, every single contaminated site is different and needs specific know-how, and a lot of the time, the pollution is a complex cocktail of all sorts of different chemicals mixed together.
But, and this is a huge but, India has a powerful, unique advantage here, its incredible biodiversity. What that means is the country is home to this vast natural library of native microbes. These little guys are already perfectly adapted to the local climate, the local soil, everything. And that often makes them way more effective than any special microbes you could import from somewhere else. It's a massive home field advantage.
So, what does the future hold? Well, to move forward responsibly, it's absolutely crucial to look at not just the promise, but also the potential risks and the concrete next steps we need to take. Now, this is a really important point, especially when we're talking about those genetically engineered supermicrobes. Releasing any kind of modified organism into the environment comes with the risk of unintended consequences. We have to be careful. So, scaling this up responsibly means we absolutely need clear biosafety rules, solid certification systems to make sure everything is safe, and real open conversations with the public about this technology.
And that leads us to this final roadmap. The path forward seems to have 3 really clear steps. First, India's got to develop national standards so everyone is on the same page, using the same safe and effective methods. Second, creating regional hubs would be a game changer. Imagine connecting the brilliant minds at universities with industry and local governments to solve problems right where they're happening. And finally, public engagement is key. We need to build trust and help everyone see that these tiny microbes can actually be our greatest allies in cleaning up the environment.
So I'll just leave you with this thought. We so often look for these huge, complex, mechanical solutions to our problems. But what if the most powerful heroes in the fight for a healthier planet have been here the whole time? Microscopic, unseen, just waiting for us to finally recognize their power.